This is lesson 10-4. We're going to be working with ratios as fractions. We'll start off with the launch problem. Just try your absolute hardest. Write down an answer and we'll discuss the solution when you're finished.
Due to high demand, a gift shop wants more fruit boxes with a 1-to-3 ratio of the number of apples to the total number of fruit. Drag fruit to each box. Write the fraction, the number of apples over the total number of fruit. Cross out any plan that does not have the correct ratio.
So I know that you can't physically drag the fruit into the boxes like it's wanting you. So just make sure that you're writing as a fraction the number of apples to the total number of fruit. And if you need to draw them into the boxes, know that you have the booklets that I've provided in class that you can do that with. Here is the answer for the launch problem. We can see that box plan 1 and box plan 2 both work, but box plan 3 does not have the 1-to-3 ratio that it was looking for. You can pause the video and read through this a little more thoroughly if you'd need to.
You have compared quantities by writing ratios in the forms A to B and A:B. A fraction also shows a comparison. So you can write a ratio as a fraction, A over B. You can write the ratio of the number of squares to the number of circles in 3 ways.
So the 3 ways that it is talking about, number of squares to the number of circles. I have 4 squares, 2, 3 circles. That's way 1. I could write it like this, 4 to 3. And it's also telling me that I can write it like this, 4 to 3. Knowing all 3 ways to write a ratio is very important, and when we take a test, you will have to provide me with these 3 ways. So again, write the ratio with the word to. You can write the ratio with a colon, and you can write the ratio as a fraction.
The table shows the number of students who play each instrument in a school band. Write each ratio in 3 ways. Part A. The number of students who play saxophone to the number of students who play drums. Part B. The number of students who play flute to the total number of students in the band.
I am going to do part A while you go along with me, and then I'm going to leave part B up to you. So again, we want to write each ratio in 3 ways, and A is writing the number of students who play saxophone, which is 13, so that's going to be my first number, to the number of students who play drums, which is 10, my second number. Again, I can write it with the word to, so 13 to 10. I can write it with my colon, 13 to 10, like this. And last but not least, I can write it as a fraction, 13 to 10, with 13 being on top because that is the first number that I stated. This is the answer to A. My answer has 3 parts because it asks me to write each ratio 3 ways. I want you to solve B on your own, and remember, you were giving me 3 ways to write this ratio. For part B, your 3 answers are right over here. 27, the word to 59, 27 to 59 by using the colon, and 27 over 59 written as a fraction. Here's our first got it problem.
A school baseball team has 5 pitchers, 2 catchers, and 12 other fielders. Write the ratio of the number of pitchers to the total number of players in 3 ways.
Our correct answer is A, 5 to 19, written with the word to, 5 to 19 written with a colon, and 5 to 19 written as a fraction. Knowing that 19 is the total number of players, you just had to add up 5 plus 2 plus 12. Here's a second got it problem for part 1.
Suppose you have a fruit box in which the ratio of the number of pears to the number of apples is 2/3. Explain what this ratio tells you about the relationship between the types of fruit in the box.
Here's a possible answer that you could have given, but again, it's writing it out in your own words, so as it says here, answers may vary. Here's the key concept.
When you write equivalent ratios as fractions, they are equivalent fractions. Recall that equivalent fractions are fractions that express the same relationship.
So even this right here is telling you that 1/2 is equivalent, over here, 1/2 is equivalent to 2/4. My blue and my red area are showing me that I have the exact amount, even though that this is split up into fourths and this is split up into halves. So one of these equals two of these, 1/2 equals 2/4. Those are equivalent fractions, and because we can write equivalent ratios as fractions, we're still solving those kinds of problems the same way.
Write two different ratios equivalent to 10/25.
Okay, let's consider something. Why would I want to write a ratio as a fraction? Wait for it. Because then I can use it to write equivalent ratios.
So I know that 10 and 25 are both divisible by 5. So 10 divided by 5 is 2. 25 divided by 5 is 5. Which means that my equivalent fraction, 2/5, is also going to be an equivalent ratio of 10 to 25. I can do the same thing with this, and I can find equivalent fractions that go along with 2/5. I could multiply by 3 and say 2 times 3 is 6, 5 times 3 is 15. I could say that 10 times 2 is 20, and 25 times 2 is 50. I could say so many different equivalent fractions, and I would be finding the equivalent ratio with that as well. I wrote all of these as fractions just so we could be how I had it up here, but just know that I can write ratios in 3 different ways, one way being fractions, the other way being with the word to, and then also being able to write it with my colon as well. So it says write 2 different ratios equivalent to 10 to 25, and I wrote 3 different ratios that are equivalent, and just know I could go on and on and on with my answer. I just stopped after having 3 examples. Now I want you to give me 2 different ratios that are equivalent to 6 to 8. It's easier because I gave you the multiple choice answers, but just know aside from the correct answer that's shown here, there are a whole bunch more possible solutions that you could have given me. The correct answer that this shows is C. 3/4 is equivalent to 6 to 8, and also 12 to 16 is an equivalent ratio to 6 to 8. Moving on to part 3.
To write a fraction in simplest form, you divide the numerator and denominator by their greatest common factor, the GCF. You can use this same process to write a ratio in simplest form. Equivalent ratios have the same simplest form.
So just to rephrase it, it's making sure that you realize that when you reduce fractions to its simplest form by using the greatest common factor, when you get it as small as you can possibly get it, you use that same process to find ratios in simplest form.
Which ratios are equivalent to 30/45? Drag the ratios to the correct bucket.
So I will be dragging the answers, but I first want you guys to answer the question of which ratios are equivalent. So know that in your options off to the side, you're going to be choosing more than one answer. Choose all possible answers to the ones that show which ones are equivalent to 30/45. So I've already dragged them. Here are the 3 other ratios that are equivalent to 30/45. Here are the 2 ratios that are not equivalent to 30/45.
Write the ratio 12 to 40 in simplest form.
The correct answer is B, 3/10 or 3 to 10. 12 to 40, they're both divisible by 4. 4 is the greatest common factor, so 12 divided by 4 is 3. 40 divided by 4 is 10, and you cannot simplify that any further.
How can you determine whether a ratio is in simplest form?
This is the last got it problem, and I just want you to type out what you think. So one way to do it is to find the greatest common factor of the 2 terms that are in your ratio. And if the greatest common factor is 1, then it's already in simplest form. If you had some sort of answer that could also work, I'll be checking them just to make sure that you're on the right page as soon as you submit them into Edpuzzle. Just know that we are going to be having a test on this shortly. We only have one more lesson after this one to do, and that would be the end of topic 10. So if you have any questions on what we've learned so far, make sure that you're coming to me and asking questions, that you're using your class time wisely, and that we're making sure that we're getting work completed in class and not just saving everything at home when you still have a bunch of questions and then you're just not preparing yourself very well. So again, make sure you come to class ready. That means ready with questions, ready to work, ready to learn, and we'll get through this together.